What if we're not alone in watching our own space exploration efforts? Imagine an alien intelligence light years away, observing humanity's first tentative steps into the cosmos. What would they think of the Indian Space Agency, ISRO, and its stunning achievement back in 2014? For a budget of only $66 million, a remarkably small sum in space exploration, they successfully guided a probe into the orbit of Mars on their very first attempt. This feat made ISRO the first space agency in the world to have a successful Mars mission on its initial try, and also the first Asian agency to reach the Red Planet. That alone is incredibly impressive, but the probe, named Mangalyaan, has been orbiting Mars for over 5 years now. So what discoveries has it made? What has it seen, and has it offered anything new beyond what the missions from NASA and the ESA have already provided? Mangalyaan took flight from India in 2013, launched by an ISRO rocket that was originally created to place satellites into Earth's orbit. Because the rocket didn't have enough power to send Mangalyaan directly to Mars, the probe needed to burn some of its own fuel to break free from Earth's gravity. It accomplished this gradually, building up speed over several orbits. When it finally reached Mars, it was placed into a long, stretched-out orbit. At its most distant, Mangalyaan is nearly 880,000 kilometers away from Mars, while its closest pass brings it just 420 kilometers above the Martian surface. This orbit is vastly different from that of NASA's Mars Reconnaissance Orbiter, which stays close to the planet to capture images in much greater detail. The reason for this difference lies in the distinct scientific goals of each mission. Mangalyaan was primarily a technology demonstration, though its scientific instruments were designed with a special focus on examining Mars's upper atmosphere. What I find particularly wonderful about this mission, however, is that they included a fairly standard camera to photograph the Martian surface. This means the raw images are in true color, showing Mars exactly as you would see it with your own eyes if you were there in orbit. The highly elliptical path also allows us to see the entire planet in a single frame, echoing the classic images from NASA's old Viking missions. I have to say, from this distance, Mars is a genuinely stunning world. The ice caps, made of carbon dioxide and water, stand out sharply at the planet's poles. Across the surface, a fascinating patchwork of different colored rocks, sediments, and dust creates a beautiful contrast. Craters of all sizes dot the landscape, and of course, some of Mars's most famous landmarks are visible, including its massive, long-extinct shield volcanoes and gigantic valley systems. What's also easy to spot, even from so far away, are some of Mars's legendary dust storms. In one striking image, a dust storm can be seen stretching for thousands of kilometers across the northern hemisphere. These storms are powerful enough to last for weeks or even months, at times blocking nearly all sunlight from reaching the surface beneath their thickest sections. Storms like these created huge challenges for the solar-powered rovers Opportunity and Spirit. In other global snapshots of Mars, smaller, more localized storms can also be observed. Clouds formed by water ice, known as orographic clouds, are often spotted over the volcanoes of Mars. It's true, these are indeed clouds of water ice. While Mars's atmosphere is much thinner than Earth's and has lost most of its water over time, a small amount of water vapor still lingers. In one particular image, we can see 3 smaller volcanoes with these orographic clouds forming above Elysium Mons, the main volcano in the region. Orographic clouds appear when air is forced upwards as it passes over high terrain, like mountains. During a closer flyby over Elysium Mons, the clouds are still there, but what becomes more apparent are the trenches that surround the volcano. These are called fossa trenches, and they are created by the stretching of the tectonic plate they sit on, a process often triggered on Mars by the sheer weight of the massive volcanoes nearby. The fossa grow larger as more material from the sides collapses inward. You can think of it like a chain of connected sinkholes on Earth. But instead of material washing away underground to create the pit, as happens on Earth, the fossa on Mars are formed by a fault line deep beneath the surface, sometimes reaching depths of up to 5 kilometers. A detailed look at one of the fossa reveals something truly remarkable. Right in the center of a specific image, you can make out what looks like a tall, swirling column. Magellan had, by chance, captured a massive dust devil, with its shadow stretching for several kilometers. Once you spot that one, you'll start to notice a few more in the same picture, each casting a long, twisting shadow. Orographic clouds have also been seen over Olympus Mons, the tallest volcano in our entire solar system. From its base to its summit, Olympus Mons is 3 times the height of Mount Everest and measures 600 kilometers across. Because of its immense size, it's easily visible and recognizable, even from this high altitude. From this perspective, you can also clearly see the paths where lava from ancient eruptions flowed down onto the surrounding plains. If you look a bit further across the landscape, you'll find 3 more large shield volcanoes, with a few smaller ones situated to the north. You'll also start to see a strange, maze-like patch of terrain, which is fittingly named Noctis Labyrinthus. Much like the Elysium Fossa, Noctis Labyrinthus is believed to have been formed by the immense weight of the volcanoes to its northwest, but in this case, it might also be due to collapsed magma chambers deep beneath the surface. Research into its origins is still ongoing. Connected to Noctis Labyrinthus is the famous scar of Mars, Valles Marineris. What I truly love about these images is that, just like the ones from the Viking missions, you can see water ice fog settled inside the vast chasm. This valley stretches for 4,000 kilometers, and channels appear to flow out from it to the east, leading into chaotic regions that are similar to, but smaller than, Noctis Labyrinthus. This hemisphere of Mars sits at a lower elevation than the rest of the planet, which suggests that these outflow channels, which look very much like river channels on Earth, once emptied into an ancient ocean. Ground-based rovers have since found more evidence supporting this ocean theory, discovering water-rich minerals in these very areas. Another truly captivating landmark on Mars is Casse Valles, which is located to the north of Valles Marineris. Once again, it presents a fascinating outflow channel that starts in the east and flows westward, emptying into the same basin as Valles Marineris, but further north. In the southern regions, most scientists believe these channels were carved out by enormous mega-flooding events in the distant past when liquid water was abundant on the Martian surface. There is also some discussion that glaciers may have played a role in shaping these channels. In reality, a great number of outflow regions lead into this ancient ocean basin. Here you can see Ares Valles again, another feature likely formed by massive flooding events. All of these channels are simply too wide to have been sustained by a constant river system, at least not on this scale. A very large but strange crater-like feature can be seen in the Magellan images. This is Orcus Patera, which is 380 kilometers long at its widest point. Scientists are somewhat baffled as to how this formation came to be, since craters are almost always circular. Additionally, Orcus Patera isn't very deep, only about 500 meters. Volcanic activity might be one explanation, but there is no caldera, so no single theory has been definitively accepted by scientists so far. What do you think could have created it? Some of the images that focus on the limb or edge of the planet have also managed to capture Mars's atmosphere, which I find quite beautiful. Some shots taken at a very low angle can even pick out a layer of clouds high up in the Martian atmosphere. And because of Mangalyon's elliptical orbit, sometimes Mars's moon, Phobos, passes between the planet and the probe, allowing it to be photographed against the backdrop of Mars. The last thing I want to point out in this video is the dominant wind direction on certain parts of the planet. Even though we are quite zoomed out in this image, which covers a few thousand kilometers, we can easily see where craters have blocked darker dust from being carried across the surface by the wind. The wind in these areas must have blown in a consistent direction for a very long time for the effect to be so visible from space. A closer look at the surface reveals how this same effect can happen with smaller craters as well. The years 2020 and 2021 have been and will continue to be huge for the exploration of Mars. 3 different missions to the Red Planet were sent from 3 separate countries in 2020: the United States, China, and the United Arab Emirates. You see, there was a launch window during the summer of last year when Earth and Mars were perfectly aligned for spacecraft to make a quick journey. All of them, with the exception of the China mission, have now safely arrived at their destination, with the Chinese rover mission expected to touch down in May. Al-Amal, or the Hope mission, represents the UAE's first attempt to reach Mars. It is an orbiter built to study the Martian weather and atmosphere. According to the Emirates Mars mission team, the probe will be the first genuine weather satellite to orbit Mars. So, what exactly does that mean? Stay with me in this video, and together we will explore the Hope mission, what it has discovered so far, and what scientists in the UAE hope it will ultimately achieve. The United Arab Emirates Space Agency was formed in 2014 with the goal of inspiring interest in space science research and exploration throughout the Arab nation. The UAE and other Arab nations have been working to diversify their economies away from oil, using the revenue from oil to grow and invest in technology and knowledge-based sectors. This is a great thing for space exploration, as the space agency has already promised that they will share all the data from the mission with the international community. Remarkably, the Hope mission is the UAE's first journey beyond Earth's orbit. They skipped the moon entirely and went straight for Mars with a relatively small budget of just $200 million. The Hope mission was built with international assistance from the University of California, Arizona State University, and the University of Colorado Boulder, which is where the spacecraft was finally put together. The UAE also worked with India's space program, ISRO, in the development of the spacecraft, as ISRO had already successfully sent a probe to Mars. After 5 years of planning and construction, Hope was launched aboard a Japanese rocket from the Tanegashima Space Center in Japan on the 19th of July, 2020. Following a 7-month journey through space, Hope successfully performed an orbital entry maneuver on the 9th of February 2021. This achievement made the UAE the 5th country to reach Mars and the 2nd country, after ISRO, to successfully enter Martian orbit on its very first try. As I mentioned, the Hope mission will be gathering scientific information while it orbits Mars, with a specific focus on observing the planet's climate and atmosphere. During the spacecraft's design process, a meeting was held with the NASA Mars Exploration Program and Analysis Group to pinpoint gaps in our knowledge of the planet. As a result of this meeting, it was fitted with 3 scientific instruments that would help detect water vapor and water ice in the atmosphere itself, measure the atmospheric temperature, and it also has the ability to look for trace amounts of oxygen and hydrogen particles that have escaped into space. Furthermore, it has a high-definition digital camera on board, which has already been used to take some truly amazing pictures. So, why these specific instruments? Well, one of its main scientific goals is to figure out why there is no water on the surface of Mars. Mars cannot naturally hold liquid water on its surface because of its thin atmosphere. You know how on Earth, the higher you go in altitude, the lower the boiling point of water becomes. That's because at higher altitudes, the atmosphere is thinner, which means there is less air pressure pushing down on the water. On top of Mount Everest, water boils at only 70 degrees Celsius. On the surface of Mars, the atmospheric pressure is equivalent to being 30 kilometers up in Earth's atmosphere, meaning it's so thin that water can turn to vapor very quickly. It wasn't always this way on Mars, though. Previous Mars missions have found evidence that Mars might have once had a thicker, warmer atmosphere, and even oceans of liquid water early in its history, a stark contrast to the cold, dry atmosphere it has today. This makes us suspect that Mars has since lost most of its atmosphere to space, and alongside NASA's MAVEN spacecraft, which is already orbiting Mars, HOPE will help us understand why this is happening. To give some background on this, our Sun constantly releases very high-energy photons. When these photons arrive at the Martian atmosphere, they crash into the atoms there, knocking their electrons loose. This means that atoms become ions, or particles, with a negative charge. As the solar wind blows past the planet, most of these ions are swept away because they are pulled by the magnetic field contained within the solar wind itself, in a process known as sputtering. Even if they don't leave the atmosphere themselves, they might knock other particles out instead. Sputtering is always happening, but its effectiveness decreases over time as the Sun gets older and less active. Billions of years ago, when Mars might have had a thick atmosphere, sputtering would have been happening at a much faster rate than it is today. Over the course of those billions of years, Mars is thought to have lost more than 65% of its atmosphere. Earth also loses hundreds of tons of its atmosphere every day because of radiation and sputtering, but our planet has global processes that also replenish the atmosphere. It also has its own magnetic field, which helps to prevent significant atmospheric loss, as most of the solar wind is bent around our planet. Consequently, the atmosphere doesn't interact as much with the solar wind. On Mars, there is nothing to stop the solar wind from directly hitting the Martian atmosphere. Mars probably did have a magnetic field until about 4 billion years ago, but for some unknown reason, the dynamo in its core stopped working. Mars's smaller mass and density compared to Earth's might be one reason for this. The theory is that Earth's magnetic field is created by a dynamo effect caused by the rotation of the planet's core. This happens when a liquid outer core is constantly moving around a solid inner core with the motion generated by the planet's spin. Mars's lower mass and density likely meant its interior cooled down much faster than Earth's, causing Mars's core to solidify completely, which might explain why we still have a magnetic field and Mars does not. Interestingly, investigating Mars's dynamo is something NASA's InSight mission is trying to do right now, which you can learn more about here if you're interested. So how can the HOPE mission help us figure out what is happening with Mars's atmospheric loss? And what will it accomplish that NASA's MAVEN spacecraft hasn't? Well, while MAVEN has a very stretched out elliptical orbit, HOPE will stay further away from the planet. This is so it can keep a daily global watch on Mars, following the Martian seasons and monitoring weather events like Mars's famous dust storms. Staying in a high orbit means that weather events can be easily tracked and compared to other areas of the planet at the same time. It will also be able to spot particles as they leave Mars's atmosphere and hopefully help MAVEN map atmospheric loss events more effectively. Combining the two sets of data will help us get a better idea of how much atmosphere Mars actually loses to sputtering. The HOPE mission also aims to find more evidence to answer questions like, did Mars ever have a warm and hot atmosphere? Was there ever liquid water on its surface? And could it have once been a place where life could survive? You might be asking why this matters to you, but what we learn about Mars will also help us understand more about how Earth was formed, as we'll be able to compare the processes that happened there with what we might expect to happen to our own planet over time. During HOPE's 2-year mission, it should provide a ton of data that will give us a better sense of our place within the universe and the solar system we call home. Earlier this year, Japan made history, but not for the reason you might think. Yes, it landed a spacecraft on the moon for the first time, putting it in the same league as the USA, Russia, India, and China, who had all done it before. However, JAXA's mission was much more important than just that. They pulled off a landing on the moon so precise it would be like successfully firing a skin cell from London to Cairo and having it land on a single, specific grain of rice. In the time leading up to the launch, it was this incredible goal of precision engineering that caught everyone's attention. Once JAXA had landed, the headlines back on Earth changed. Known as the Moon Sniper for its quiet precision, its entire mission was mainly to show just how accurate a landing we can now achieve. Because of this, the tiny spacecraft wasn't meant to survive the harsh conditions of a lunar night, yet somehow it has survived 3, leaving scientists amazed. This tough little craft kept waking up and sending back data and images from the lunar surface. Oh, and it's also upside down. Join me today on this wild ride as we look into the details of JAXA's first moon landing, what has kept the Moon Sniper working through 3 lunar nights, and how much pinpoint landings will change the future of lunar exploration. The SMART lander for investigating Moon, also called SLIM, or Moon Sniper, is a small light spacecraft about the size of a passenger car. Its mission is to study the makeup of olivine rocks near the Scioli crater, about 200 miles south of the Sea of Tranquility, where Neil Armstrong took his famous small step. This landing spot is on ground that was thrown out by the nearby crater, giving researchers a chance to study lunar rock without having to drill. By studying the rocks there, JAXA hopes to learn more about the Moon's origins, its inside, and how it was formed. SLIM also brought 2 tiny lunar excursion vehicles, LEV-1 and LEV-2, which were meant to be released from SLIM to collect some of their own data and pictures. Besides its scientific goals, SLIM is also a display of the latest in engineering and mission operations. It was meant to show how a small explorer could perform accurate lunar landing methods. This would speed up the study of the Moon and other planets by using a lighter, more precise exploration system that can land in dangerous, rocky areas too tough for larger craft. To understand how important this is, it helps to have some history. The first thing you need to know is that only about 43% of lunar landings are successful. Past lunar missions had big problems with landing accuracy, mostly because of the technology and the lunar environment. For example, the Soviet Union needed a dozen tries before they finally landed Luna 9 on the Moon. In the same way, NASA's Ranger series took 6 tries before it worked. The lack of an atmosphere on the Moon means that landers have to rely only on engine thrust to slow down, making it hard to adjust their path accurately during landing. The craft has to touch down at almost 0 speed to make sure no instruments on board are damaged from the impact. Every single Apollo mission landed dangerously close to rocks, craters, or slopes that could have caused serious damage, with very little ability to make changes in real time. The Apollo missions also all landed on the near side of the Moon, near the equator, and in almost perfect light to make landing as safe as possible. The downside of this, though, is that NASA kept sending spacecraft to the same part of the moon, which meant that real exploration of the surface was limited to this specific landing area. If we could create a spacecraft that could land in a super precise spot, we could send it to explore whatever and wherever we want. Scientists would be able to do targeted studies of different rock and soil types without needing rovers to travel long distances. This makes missions less complex and cheaper while opening up ways to explore new parts of the moon. The Moon Sniper mission cost $120 million. To compare, the lunar rovers built for Apollo 15, 16, and 17 cost $38 million to develop back in 1972, which would be about $286 million today. More recent rovers like the Chandrayaan-2 and Chang'e-4 cost around $141 million and $180 million respectively. And this is exactly what researchers are working hard on with great results. A landing footprint, also called a landing ellipse, is the area of uncertainty for a spacecraft's landing spot on a celestial body. Back in 1969, Apollo 11's targeting ellipse was 18.5 kilometers by 4.5 kilometers. Jump ahead to 2013, and China's Chang'e-3 launched with a landing ellipse of 6 kilometers by 6 kilometers. In January 2024, a JAXA lander made Japan the fifth country to land on the moon, touching down just 55 meters from the center of its 100-meter by 100-meter target ellipse, a target 8,095 times smaller than Apollo 11's. Let's take a closer look at the technology that made this happen. Moon Sniper was able to land with such accuracy thanks to its vision-based navigation system, which JAXA calls Smart Eyes. By constantly taking pictures of the moon's surface as it comes down, the spacecraft is able to find its location in real time on orbital maps made from data by other lunar rovers, including NASA's LRO, India's Chandrayaan-2, and Japan's Selene. These positions were then compared to a wide map of its location to find the exact landing site. By processing the images in real time, Moon Sniper can change its path literally on the fly, allowing it to hit its target with pinpoint accuracy. Weighing just 200 kilos without fuel, a successful SLIM landing would show that small, lightweight spacecraft can carry out complex lunar exploration missions, except SLIM didn't exactly nail the landing. While JAXA managed to get the craft on target, it kind of fell over at the last moment. But after such a precise approach, what caused this major problem? On the 6th of September 2023, JAXA launched SLIM on a path to the moon. It arrived in orbit on Christmas Day 2023 and finally went in for landing on January 18, 2024. As Japan watched closely, the approach was live-streamed. One mission team member said the slowdown to landing was expected to be a breathless, numbing 20 minutes of terror. As it made its way down to the lunar surface, one of SLIM's two main engine nozzles mysteriously broke off 50 meters above the moon's surface. This off-center push caused it to move sideways, which it tried to steady and successfully did with its smaller thrusters. The amazing part is that SLIM was able to spot the problem in its descent and find a safe spot to touch down, avoiding a crash. SLIM tipped over onto its nose. As seen in pictures from one of two autonomous probes, SLIM released before it touched down. We can see the box-shaped main vehicle on the surface of the moon, upside down, with its panels pointing away from the sun instead of up as intended. Without sunlight, it was only a short matter of time before the craft would run out of power and shut down. Soon after landing, SLIM sent a mosaic picture of its landing site using its limited battery power. With just 12% of power left, JAXA decided to turn the craft off in hopes of a possible recovery when the sun's angle changed. And indeed, just 10 days later, on January 29th, that's exactly what happened. For 2 short days, SLIM was able to power on, using energy from the sun, which had since moved its angle in the sky. But the joy was short-lived for the JAXA team, who knew the lunar night was coming, which would likely mean the end of our amazing little spacecraft. Lunar nights are a huge challenge for all moon-bound missions. They are absolutely harsh, and it's not rare for lunar craft to fail to survive a lunar night. For example, the first U.S. craft to reach the moon in 50 years, the U.S. lander Odysseus, failed to wake up after a lunar night. Much like Salyut, it had a problem on approach and landed on its nose in early 2024. Even though it went into hibernation mode for 3 weeks, it did not wake up again. Since the moon doesn't have a significant atmosphere, there's nothing to keep its surface temperature stable. During a lunar day, when the moon is facing the sun, temperatures can reach 121 degrees. During a lunar night, the moon is plunged into complete darkness, and temperatures drop to an average of 180 degrees. That's quite a big temperature swing for our little lander. What's more, days and nights on the moon are not like the 12-hour days and nights on Earth. They each last 14 Earth days. That's a fortnight of burning heat followed by a fortnight of total freezing darkness. SLIM was not built to handle a lunar night, so on the 31st of January, the mission team put it into a hibernation state for the next 14 days. It was not expected to survive, but the hopeful crew decided to try to make contact after the sun rose again, just in case. On the 26th of February, JAXA tried to reconnect with SLIM with low expectations. Imagine their complete shock and joy when SLIM responded. Their miracle moon sniper had survived its first lunar night and started sending pictures back to Earth. It gets even better. After 2 weeks of collecting data and images during its second lunar day, JAXA again put SLIM into hibernation. Surviving one lunar night is a huge accomplishment. No one thought SLIM would survive a second, but somehow it did. On the 21st of March, JAXA confirmed they had received more communication from SLIM after its second lunar night. The pattern continued in late April, when even more pictures were sent from the lunar surface after its third lunar night. SLIM had completely defied all expectations, staying functional through intense levels of heat and cold that could ruin most electronics not specially designed for these conditions. Somehow SLIM still managed to send data and images after 3 lunar nights. These pictures of the surrounding moon rocks will help researchers better understand lunar geology. In one image, SLIM took a close-up photo of a moon rock named Toy Poodle using a special multiband camera. Even though it's blurry, geologists can use this to tell the difference between the various materials that make up the rock, giving clues as to how the moon formed. After the 4th lunar night, JAXA once again tried to re-establish communication with SLIM. However, as of the 27th of May, they have not been able to confirm successful communication with the moon sniper. Despite all its heroic efforts, it's likely it has finally gone silent. Nevertheless, JAXA's first lunar landing is a major step forward in interplanetary travel. Showing that such pinpoint landings are possible opens up many other opportunities. One key area of interest for scientists is the South Pole Aitken Basin, where the moon's mantle is thought to have once been exposed on the surface. NASA is also planning a return to the moon in 2026 with the launch of their Artemis missions. Pinpoint landings like the one performed by Moon Sniper may prove essential in helping us access water ice located in permanently shadowed regions, which until now have been out of reach. Moon Sniper stands as a testament to all the progress and innovation we've achieved since the last lunar era of the late 1960s and early 1970s. As both public and private interest in going back to the moon continues to increase, missions like Moon Sniper give us a look into what the second lunar era might hold for us. High above us, circling the Earth every 90 minutes, the Prospero satellite drifts through the void. The 28th of October will be the 50th anniversary of this unique satellite's launch, and even though it no longer works, it will probably stay in orbit for another 50 years. There's something strangely sad about this special satellite that only ever did a couple of scientific experiments, yet we can learn inspiring lessons from its story. But what makes it unique? Prospero is the result of the only time a nation developed its own rocket power to put a satellite into space and then gave up that capability. Join me as we explore the early days of space exploration history of my home nation, and the first and only time they launched a satellite into space using a rocket they built themselves. Today we will be examining Prospero and the Black Arrow program of the United Kingdom. The UK officially entered the space race in 1962 when it became the third nation to operate a satellite in space, after Russia and the United States. However, that satellite, Ariel 1, was not launched with a UK rocket, but was instead taken into orbit by NASA. As America and the USSR started getting ready for their trip to the moon, the United Kingdom was keen not to be left behind. The Royal Aircraft Establishment, RAE, which was the closest thing the UK had to its own space agency at the time, first suggested the idea of building their own rockets in 1963. Until then, UK rocket science was mostly for military purposes. Blue Streak and Black Knight rockets were created using the scientific knowledge of German scientists who had been brought to Britain after World War II, much like what happened in America around the same time, and they were meant to carry nuclear weapons. However, the RAE wanted to make rockets that could carry satellites into space for scientific and communication reasons. Their first request was for a low Earth orbit rocket that could take a 144-kilo satellite into orbit. The request was approved in 1964 but was quickly paused because of an upcoming general election. A new government took power and restarted the process, but chose to cut the number of test flights from 5 to 3. This was the start of the slow end of the UK's rocket abilities before they had even really started. Using the technology of the Black Knight rockets, RA scientists started to create the Black Arrow, a 3-stage rocket that, while it used much of the same technology as the Black Knight, was much more powerful, producing an initial 256 kilonewtons of thrust compared to the Black Knight's 96 kilonewtons. The first stage would carry the payload for the first 2 minutes or so of the launch before breaking away. The second stage would burn for 2 more minutes before splitting in half, letting go of the third stage and the payload. After separation, the third stage would burn for 1 minute, and a minute later, the payload and final stage would separate. Parts of the Black Arrow were built across the UK, with a lot of the assembly happening on the Isle of Wight, and the launch site itself was in Australia, a Commonwealth country. Other test sites closer to home had been thought about, but in the end, it was decided that the risk of spent rocket parts falling on places in the UK was too high. However, the Wilson government at the time was having money problems and was looking for ways to cut its spending. They had another project going on that was needing a lot of investment, the supersonic airliner Concorde. And the UK government didn't want to invest in both programs. Ideally, they wanted to avoid spending money on either. Ironically, they decided that Concorde had better long-term prospects for the UK economy than satellite technology, which is a pity because Concorde ended up being grounded completely in 2003. It wasn't that they thought satellites wouldn't help the economy, it was that no one could agree on who should pay for the development costs. Adding to this, unfortunately, the Black Arrow program also started having technical issues. Although its first flight, testing its first two stages was planned for 1968, it wasn't until 1969 that the first Black Arrow launched, and that launch was a failure. An electrical problem caused some of its combustion chambers to pivot, making the rocket roll uncontrollably. It eventually fell apart and was completely destroyed. The second launch, where it was again testing the first two stages, went successfully, but the Black Arrow's third and final test launch, where it first tried to reach a full orbit, was also a failure. Its second stage had an oxidizer that didn't pressurize, which meant the second stage cut out too soon, and the whole rocket with its fake payload failed to get to orbit. During this time, France, Japan, and China all successfully launched satellites using their own rockets. On the 29th of July 1971, the UK government chose to cut its losses and cancel the Black Arrow project. This was a huge blow for the RAE. However, by this time, the fourth Black Arrow had already been built and sent to Australia, along with the satellite that went with it. The government finally gave the okay for the final launch. This satellite was made to test the technologies needed for communicating with satellites. As such, it had tape recorders, a micrometeoroid detector made to measure how often small particles are in space, and multiple designs for solar cells to see which would be the most effective. At first, this satellite was named Puck by the RAE, not Prospero. This followed the tradition at the time of Ray satellites being named after Shakespearean references. Puck and his predecessor, Ariel, were both fairy characters in Shakespearean plays. They were beings of the air, of tricks, and of magic. When the project was canceled, however, the RAE team changed the satellite's name from Puck to Prospero. Prospero, a wizard in the Shakespearean play The Tempest, was a powerful magician too, but in the end, he gave it all up to become a normal human. It's a sad sign of how the RA team must have felt. Even though they would be allowed to launch their last rocket, they knew they would never do it again. Britain was giving up on its space race. It would, in the future, pay other nations to carry satellites into space, as this was seen as more economical. To the RA scientists, it must have felt like they were giving up the magic. This made the successful launch of Black Arrow and Prospero on the 28th of October 1971 even more bittersweet. Before this, a Black Arrow had not successfully carried a payload all the way to low Earth orbit, and now, just when it had finally shown it could work, it was stopped. To be fair, Prospero's launch didn't go completely smoothly. When the third stage of the Black Arrow rocket separated, one of its thrusters kept firing and hit Prospero as it went by. Luckily, while this knocked off one of Prospero's 4 antennae, Prospero stayed in a stable orbit and was able to have a successful mission. It taught British scientists a lot about designing satellites for space, knowledge that would be useful as Britain went on to specialize in the field of satellite technology. Unlike in other countries like the US, the successful launch of their first satellites didn't even make the UK front-page news. The public didn't really notice it happened. It was a full 2 days later before any newspapers even mentioned it. The UK government said that the successful launch was great news, but did not restart the program. Britain became the 6th nation to launch a satellite into space using its own rocket. In 1973, Prospero's tape recorders stopped working. It could still be contacted, but government scientists eventually stopped doing so when they closed their satellite monitoring station in 1996. Prospero was officially shut down. However, it didn't immediately go quiet. Amateur satellite fans kept contacting Prospero until about 2004, where its faint signal, powered by its solar panels, could still be heard. As we get to the end of October 2021, we are near the 50-year anniversary of Prospero's launch. Although Prospero has now gone silent, that might have been the end for Prospero and the Black Arrow project if it hadn't been for a surprising twist in the story. Thanks to the huge growth of the space industry in 2010, the UK government decided to get back into space. It created the UK Space Agency and is building several spaceports to start redeveloping its ability for rocketry. And thanks to the progress made in satellite technology in the years between, satellites are now smaller than they were a few decades ago. As such, only a smaller rocket is needed to carry such payloads into low Earth orbit, a rocket just like Black Arrow. In fact, Black Arrow is so perfect for this niche that the Edinburgh-based space technologies company Skyrora has heavily based their rockets on its design. Their Skyrora XL rocket shares similar sizes with the Black Arrow and uses the same type of kerosene and hydrogen peroxide mix for its fuel. In 2018, the company got the remains of Black Arrow R3 to display in their offices as a tribute to the legacy of this important rocket. And amazingly, as part of an effort to remove space junk from orbit, they even have plans to find Prospero and bring it back down to Earth in one piece. So maybe Prospero will not end up lonely and forgotten. Although for almost 50 years it seemed that Prospero and Black Arrow were just a footnote, a failed experiment as part of a project that was doomed before it even started, their legacy is proving to be much more influential than any of the array scientists could have guessed at the time. And maybe the magic does not need to be given up after all. No single person builds a spaceship. The Jupiter Icy Moons Explorer, JUICE, has just been launched, and it would be too simple for me to say that ESA built it. While that is true, it makes the huge process that turned a vague idea on a design board into a real behemoth of metal and carbon fibers shooting up through the atmosphere seem easy. Building a probe like JUICE is a massive job. For JUICE, it was a task that involved 18 countries, 60 companies, an 11-year 5-city tour, and 350 million euros of technical skill, equipment, and resources. By looking into the story of JUICE's creation, we get a better appreciation for the amazing process by which such craft are made. JUICE launched on the 14th of April 2023, but that is only half the story. And it's time to explore the first half of JUICE's journey, the half that happened before the probe even left Earth. Jupiter's icy moons, Callisto, Europa, and Ganymede, hide a fascinating secret under their surfaces. All are thought to have deep subsurface oceans, some of them bigger than all the oceans on Earth combined. These are of huge interest to the scientific community, as such large bodies of water could possibly make these moons habitable. Water and nutrients are two of the key ingredients for life. We have deep-sea ecosystems here on Earth that live on nothing else. Could microbes also have formed in the depths of these moons' icy oceans? Without more information about those oceans, it's hard to know their exact appearance, their features, what they hide, and where liquid water or ice is present. By better understanding these icy worlds, scientists can get insight into how they formed and changed in the past, and can better predict the chance of life starting within them and other icy worlds beyond our solar system. As such, it was decided on the 2nd of May 2012 that a new mission to explore these moons should be launched. JUICE won over budget proposals for a new gravitational wave observatory and an advanced telescope for high-energy astrophysics, becoming the European Space Agency's main focus for a large-scale mission from 2015 to 2025. But that decision needed more detail. JUICE was still only a partly formed idea. Even after it was decided that Jupiter's icy moons should be explored, the next question was what scientific instruments JUICE should carry. to help with this exploration. So just 28 days after JUICE was announced, ESA reached out to the wider scientific community, asking for their ideas on what they would like to see on JUICE. In the end, 10 scientific instruments were chosen, including cameras with a spatial resolution as fine as 2, 5 meters per pixel, spectrometers that can detect features down to a resolution of 75 meters, a laser altimeter, and plasma and particle monitors. A magnetometer would study Jupiter's magnetic fields, and an ice-penetrating radar would look through its surface to see the structures that lay underneath. These parts would be provided by various member states of the European Space Agency, 16 nations in total, along with help from the US and Japanese space agencies. Airbus Defence and Space was picked as the main company responsible for building JUICE. ESA had set the mission's goals, but it was up to Airbus to design, develop, put together, and test JUICE before delivering it to the Guiana Space Center in France for launch. And it would be no easy job. JUICE would be a solar-powered probe working at the very edge of how far from the sun solar panels could be expected to work. At 740 million kilometers, sunlight is so faint it's equal to about 3% of what we see on Earth. The panels for JUICE would have to be huge, 85 square meters, to give the power needed for its various instruments. Those instruments would need protection. Jupiter's environment is full of intense radiation, which will damage unshielded parts. Passing through its shadow is so cold that temperatures reached 250 degrees, but JUICE would be passing Venus on its way to Jupiter as part of one of many gravity assists. So it also needed to be able to handle hot temperatures. It was designed to study magnetic fields, so its own internal electronics couldn't make magnetic fields that could interfere with its sensors. And as there was a chance it was going to environments where life could thrive, the utmost care had to be taken to make sure no Earth-based bacteria would be brought to those environments once the mission ended and JUICE crashed into the surface of Ganymede. These designs took time, and it wasn't until 2017 that Airbus felt the designs were finished. Later that year, the first parts began to appear. One such part was RIME. JUICE is a large craft, and its radar for icy moon exploration, RIME, is a massive 16 meters long. It would be incredibly sensitive, able to penetrate 9 kilometers of ice to see structural details with a resolution of 50 meters. Testing the part involved making a model version of JUICE and then hanging it under a helicopter, which then flew it over the fields near Friedrichshafen, Germany. I wonder how far into the Earth it was able to see. It must have been a funny sight for any residents in the area. Another model was tested in Noordwijk, the Netherlands, at ESA's main facility for spacecraft development and testing, ESTEC. JUICE's parts would need to handle the freezing cold of space, so technicians there used liquid nitrogen. They had 25,000 liters of it to freeze the chamber down to 180 Celsius. However, JUICE would also be traveling near heat sources, so they at the same time blasted it on one side with an array of lamps and mirrors, raising the temperature to 200 degrees. The JUICE model luckily proved able to handle these incredible temperature changes. However, these were only models. The real JUICE, the one meant for launch, began its life in Madrid. There, in July 2019, its towering 580-kilo chassis was put together. You truly get the scale of the probe by watching the technicians working next to it. The finished JUICE weighs 5,300 kilo, although about 3,000 kilos of that is the chemical fuel it needs to perform its maneuvers. JUICE needs a lot of juice. Just a month later, JUICE opened its eyes. Its navcam had been finished in Liège, and what better target for it to see than its eventual destination, Jupiter? The image at this distance is a bit pixelated, and Jupiter's saturation is bright because it was trying to also see Jupiter's moons. But even before it was fully put together, JUICE had already set its sights on its target. But the chassis was not yet ready to get its eyes. First, it left Madrid, traveling across Europe to Lumpolshausen, Germany. There, it would get its thrusters, one large 400-Newton main engine and 20 smaller thrusters. Next, it took a short trip to Friedrichshafen, where its technical equipment started to be put into it. This long process took a whole year as each part was carefully added and tested. Balloons were used to simulate weightlessness in space, letting the massive 10-meter magnetic boom practice unfolding itself. Like many craft, JUICE would need to fold itself to fit onto the rocket that would later carry it into space. But finally, this stage was done. Of course, this meant more testing. JUICE was taken to ESTEC, as it was home to the largest vacuum chamber in Europe, the Large Space Simulator, LSS. Moving the large JUICE into the even larger LSS was a 2-day job. Finally, however, after careful transport using massive crane equipment, JUICE started its testing. Meanwhile, its parts, like its antenna, were tested in ESTEC's Blue Room. This unique room is a great place for trying to receive delicate radio signals. The blue spikes that make up the room effectively cancel out all other sounds and stray signals. RIME's 16-meter antenna was scaled down to about 80 millimeters for these tests to use the facilities. By using a better frequency, the tests went well, and within a few months, JUICE was once again on the move. This time, it was headed for Toulouse, France. It was getting closer to its eventual launch site, but it had one more step to make along the way. What probe would be complete without its solar panels? Made of 2,356 solar cells each, JUICE's panels would also fold up before launch, only extending once the probe was safely in space. JUICE was getting 10 panels in total, 5 on each side, and unlike the other parts, which would be hidden in protective shielding, these panels would have to handle the heat and radiation of space on their own. They had to be maneuverable, as too much energy could cause JUICE's internal workings to overheat. Power would be controlled carefully. All of this had to be done under the strictest conditions. Clean rooms were used throughout this process to reduce the risk of dust and bacteria contaminating the equipment. JUICE was a bit behind schedule, so it had to be flown into Toulouse, being one of the first times this had happened. This final stage of integration and testing was clearly not easy, as it wasn't until January 2023, a year and a half later, that JUICE was finally ready, and the rest of the story you may already know. JUICE was taken to French Guiana, and on the 14th of April, aboard an Ariane 5 rocket, it was launched into space. It will now spend the next 8 years traveling through space, doing 3 gravity assists around the Earth and 1 around Venus. Finally, in 2031, it will arrive at the Jovian system and start its careful evaluation of the icy moons there. The amazing Ganymede, Callisto, and Europa. In time, and assuming nothing goes wrong, the data and answers it will give may offer us insight into whether life could exist under those frozen surfaces, and eventually, in 2035, its mission will end, and it will crash into Ganymede, its mission hopefully a huge success. But it's important to remember just how much of its journey has already happened before it could leave the planet. JUICE represents a massive engineering feat involving hundreds of people, and while we eagerly await the results of this work, it's important to recognize and celebrate the skill that made its very existence possible. If JUICE ultimately finds the answers scientists hope for around Jupiter, it will only be because of the great effort that took place here on Earth. Venus, our sometimes close planetary neighbor and our sister world, similar in size to Earth, but about 40 million kilometers closer in orbit to the Sun, the second planet of our solar system, has long been a source of stories, myths, and legends. In more recent times, however, we have moved past seeing just that bright circle near the sun at the beginning and end of the day. Starting at the peak of the Cold War, many robotic missions have been sent to Venus to observe, orbit, and in some cases, even land. And using technology that sees not just visible light, but also the infrared, ultraviolet, and radio spectra, what we have found is a world that is different from Earth in almost every way imaginable. Join us as we journey to the star of the morning and the evening, using both old and new technology to uncover the secrets of Venus and ascending through its thick atmosphere to arrive at the surface of our closest companion. As the second brightest object in the night sky, and also the closest, besides the moon, in terms of distance at times, Venus has always caught the attention of those who look up at the heavens. But even today, interplanetary travel is hard, and at the height of the Cold War, it was even harder. Of the 15 missions launched to explore Venus between 1961 and 1967, only 3 were called successes in terms of meeting their specific goals: Mariners 2 and 5 from NASA and Venera 4 from the Soviet Lavochkin. Successful atmospheric entries with Venera 4, 5, and 6 soon followed, and in the late 1970s, the USSR finally reached a major milestone with Venera 7, the first space probe to land on the surface of another world and last long enough to send back information about it. Let's now go on a journey together with that same spacecraft, going down through what were found to be the many layers of the Venusian atmosphere it met, and finally arriving on the surface. Still floating through space, Venera turns toward Venus as it starts its descent onto the planet. Venus's upper atmosphere is before it, stretching from the edge of space at about 250 kilometers above the surface and going down to about 60 kilometers above it. Here, it sees nothing but a thin haze. 99% of Venus's atmosphere by mass is below this point. This makes Venera's descent through this layer easy enough, much like our own atmosphere would be at similar heights. But Venus's upper atmosphere's chemical makeup could not be more different, a sign of what is to come as we and Venera go down further. Instead of mostly nitrogen and oxygen, as on Earth, we start to find traces of carbon dioxide. It's not enough to cause big effects on the temperature at this height, but it's important as a sign of what is below. Other than the chemical difference, however, at this height, the atmosphere acts roughly the same as that of our home planet at similar heights, with huge temperature differences between day and night, highs of 37 degrees to lows of 143 degrees. For Venera, this is the easy part. An interesting side effect of the noticeable presence of carbon dioxide is the existence of some oxygen atoms, which give off infrared radiation that could be seen by telescopes and spacecraft. In this image, taken by the Venus Express orbiter in the infrared wavelength, the blue shows the airglow caused by the oxygen high in the Venusian atmosphere. As Venera moves down through the layers, it reaches the main visible cloud deck of Venus at about 60 kilometers from the surface. The thick, dull yellow that we think of with pictures in visible light is almost entirely because of this cloud deck, which ends about 40 kilometers from the ground. In this part of the atmosphere, ultraviolet radiation from the sun breaks down carbon dioxide into carbon monoxide and single oxygen atoms. These atoms then easily react with sulfur dioxide and water vapor, 2 other trace compounds in the Venusian atmosphere, to make the clouds of sulfuric acid that we see. This is the calm before the storm, the relatively mild region before the real hell that Venera must soon enter. As you can immediately see, The surface of Venus cannot be seen through the planet's thick cloud cover, so Venera will have to go on blindly. That same cover reflects about 3/4 of the sunlight that hits Venus, as the ice crystals made from the sulfuric acid that floats in the atmosphere are extremely reflective. This reflectivity plays a big part in explaining how bright Venus looks, both to passing satellites and to observers on Earth. Remember, it's the second brightest object in the night sky. When we look at those mustard yellow clouds in the visible spectrum, they look thick and hiding, showing little of what is underneath. However, we have an advantage that Venera did not: infrared sensor technology. In the infrared spectrum, things look very different. This image, taken by the JAXA spacecraft Akatsuki, brings things into much sharper focus, showing clear light and dark spots and bands wrapping around Venus's atmosphere. And here's where we clearly see the thick carbon dioxide makeup of the atmosphere. Indeed, carbon dioxide is an effective greenhouse gas, trapping the heat from the sun, which results in an incredibly high surface and atmospheric temperature. Under the view of infrared observation, this becomes very clear as the whole surface glows under the heat made by the thick layer of carbon dioxide. The dark patches and stripes are the previously mentioned clouds of sulfuric acid, and we can see them high above the much brighter, thick, and hot carbon dioxide layer near the surface. Can you imagine what Venera would go through as it travels through this inferno? Sulfuric acid attacks its outer casing. Winds blow at 100 meters per second, 60 times the rotation speed of the planet, fast enough to go around the planet in just 4 days. The temperature, which at a height of 50 to 55 kilometers ranges between 25 to 75 degrees, rises sharply, reaching scorching levels. Surface air pressure on Venus is 75 to 100 times what you'd find on Earth. To compare, it's like having a whole car sitting on your thumbnail. As Venera goes down further, however, even stranger conditions can be found. Once Venera passes through the bottom of the sulfuric acid cloud deck, it comes into clean air once again, but conditions here are strange. The pressure here is now so huge that it's starting to affect the carbon dioxide in the atmosphere. The density of carbon dioxide at this level is so high that it no longer acts as a gas, but more as a kind of supercritical fluid, a state of matter somewhere between liquid and gas, where a substance takes on some characteristics of both. The winds slow down here after the confusing fast speeds of the upper clouds. The atmosphere below is so dense that winds move at little more than 5 kilometers per hour. It would feel like wading through water with a slow but unstoppable current, but in a river that is 464 degrees Celsius, hot enough to melt lead. But what can modern technology tell us of these layers? To further show the immense heat at this altitude level on Venus, let's look at a picture of the lower atmosphere of Venus taken in the near-infrared range, a wavelength of 2.3 micrometers by the Galileo satellite. The red-hot areas of the lower atmosphere are clearly visible, as are the darker patches caused by the clouds of sulfuric acid higher in the atmosphere. The lower parts of the Venusian atmosphere are incredibly hot, and distinct layers of that atmosphere exist, differing in both temperature and makeup. To further show the differences between the atmospheric layers of Venus, let's now look at the layers we've seen so far under ultraviolet light. While the images, again from the JAXA spacecraft, taken in the 283 and 365 nanometer wavelengths, do not show as much contrast in color and brightness as the infrared images, they do show more variance than those seen in visible light. The areas of darkness and blotchiness of the cloud layers show that ultraviolet light is being absorbed rather than reflected. But exactly what chemical or combination of chemicals causes this absorption is still a topic of debate in the astronomy community. Clearly, there are elements and compounds in the Venusian atmosphere that continue to escape our attempts to find and classify them. And on the topic of Venus's atmosphere defying explanation, here's a look at Venus's poles in the infrared. Notice anything strange about them? Present at both Venus's north and south poles are large polar vortices, about the size of Europe, whipped up by those 100 meters per second winds. What's truly weird, though, is that they have not just one central eye, but two, and scientists are still not completely sure why. Venus's complex, highly variable polar vortices are very hard to model, as they can change on timescales of less than 24 hours, making them quite a mystery. But once it had traveled through the mysterious atmosphere, what did Venera see down there? Let's finish our journey through the thick, acidic clouds and arrive at the surface of our closest companion. Earlier, we saw the very first image ever sent from the surface of Venus. Because of the massive cloud of sulfuric acid hiding any view from space, the only images of Venus that show the surface in visible light are those that have been taken from a lander on the surface. And of those, we only have 6, taken from 4 of the Soviet Venera probes that landed, such as our Venera 7. The air is surprisingly clear. Scientists had wondered if everything would be hidden by a thick haze, but this doesn't seem to be the case. Everything is a dull yellowish color, the color of the acidic makeup of the atmosphere. And while we might be surprised to find solid rocky ground under the thick, crushing air of Venus, that ground is also completely desolate. It hints at ancient lava flows now hardened into flat plains and eroded under Venus's intense atmosphere. Everything looks very dry, which is not surprising given the scorching heat. Maybe a billion years into the future, when the sun's brightness has increased enough, we might see similar runaway greenhouse effects and results on Earth. But here, we must leave Venera. The Venera series of probes, including the one whose journey we have been following, never lasted more than a couple of hours on Venus's surface because of the mix of heat and crushing pressure. Their images give us a brief but crucial look into conditions down there on the rocky ground. But although these 40-year-old images are the only cases of photographs being sent from the planet's surface, there is another method we can use to learn about the geography and topography of Venus. It's not infrared or ultraviolet. Neither infrared nor ultraviolet imaging can get through the thick, cloudy atmosphere to clearly see and map the surface. You need something different. Enter radar imaging. The USSR started the process of using radar to map the surface of Venus with their later Venera models 15 and 16 in 1983, making images with a resolution of 1 to 2 kilometers on the ground. This was improved on about a decade later with the NASA Magellan probe, which between 1990 and 1994 managed to map about 98% of the Venusian surface with a resolution of 120 meters. The images made using the radar data are truly amazing, showing huge volcanic activity, massive cratering, and a surface that is, geologically speaking, pretty young, possibly because of the intense volcanic activity resulting in truly vast lava flows. A composite image of the surface made from data from the Venera, Pioneer, and Magellan missions looks truly amazing, with surface details from volcanoes to valleys to craters and chasms shown in clear relief. The amazing utility of radar imaging to get through the clouds and show what is on the surface of Venus has greatly improved our knowledge about the planet. And isn't the hidden beauty of it all truly remarkable? So, with all we now understand about our nearest planetary neighbor, what is left to be discovered from Venus in the future? The answer is a lot. In recent times, by far the biggest news about Venus has been the discovery, or maybe not, of the gas phosphine high in the Venusian atmosphere. In 2020, measurements from the James Clerk Maxwell telescope showed the presence of trace amounts of the gas. Phosphine is made through a variety of different processes, but one of those, and the one that excited everyone, is through microbes in low oxygen environments. Life in one of the most unlikely, hellish places imaginable. What an outcome that would be. However, later studies found no such phosphine again, and by 2022, the idea of it being present in the Venusian atmosphere had been dismissed by NASA. It would seem that the findings of the first study were wrong. But then, Professor Jane Greaves of the University of Cardiff went on record at a prestigious meeting in 2023 that the JCMT had found phosphine once again, this time deeper within the atmosphere of Venus. Hopefully, future missions will give us a definite answer to this truly tantalizing question. Many other questions are waiting for answers too. Why, for instance, did two planets, Venus and Earth, so similar in size, evolve so differently? Was there, in fact, liquid water on the surface once upon a time? What is a more accurate picture of the chemical makeup of both the Venusian atmosphere and the surface that might help answer these puzzles? After decades of being relatively ignored in favor of Earth orbit assignments and outer planetary probes, Venus has suddenly gained interest again. Several missions will be launched for Venus within the next 10 years. These missions come from the USA, ESA, Russia, China, India, and even one private American venture, the Venus Life Finder. With any luck, one or more or all of them will lead us on a journey of great discovery about our beloved star of the morning and evening, revealing a wealth of information and answering some of our burning questions about Venus. So there you have it. Observing Venus through a variety of different wavelengths has given us far more knowledge than visible light alone could offer. We have been able to see volcano and crater formations through kilometers of opaque clouds, determine some of the chemical makeup of both atmosphere and surface, and use infrared imaging to make the invisible visible to us all. All of these have given us invaluable hints as to why the conditions on it are so extreme, and just maybe that there is the possibility, however slim, of simple microbial life on our closest neighbor. By 2045, America may not be the leading space power. In April 2021, the Director of National Intelligence released a report stating that within 3 decades, another country was poised to match or even exceed the U.S. as a premier space leader. The report also suggested that by 2030, this other country would likely achieve world-class status in all but a few space technologies. You can probably guess which nation it is: China. There is strong evidence to suggest this could happen. China's economy has rapidly grown over the last 50 years, catching up to America's, with some analysts forecasting it will surpass the U.S. by 2035. And while the United States has a significant lead in space spending, China currently holds the second position and is achieving some technically remarkable feats, even with a smaller budget. You may have heard that China has landed a rover on Mars, making them only the second nation to do so, and they even became the first to send another rover to the far side of the moon. But China's goals don't stop there. So, what are the objectives and aims of this rising power? What has China accomplished and discovered in space so far? Where do China's leaders see their space program in 10, 50, or even 100 years? And what projects are Chinese scientists developing that have prompted American analysts to worry that NASA's lead is quickly shrinking? Join me today as we take a closer look at the U.S.'s biggest rival in the modern space race and explore what the future might hold based on China's ambitious plans for our solar system. To begin, China wasn't always a major space power. Back when Mao Zedong declared the official establishment of the People's Republic of China in 1949, the nation as a whole did not have the industrial capacity to match countries like America and the USSR. So, around the time the Soviet Union initiated the first space race in the mid-1950s, China's Communist Party saw the need to try and transform their largely agricultural nation into something more modern. However, their great leap forward turned into a great leap backward. As farmers were moved from their private farms and reorganized into communal labor farms and factories, they were unable to produce enough food to even match their previous output, resulting in 30 to 45 million deaths from starvations and execution. China's economy actually and predictably shrank during this time. And things did not get better for China's space program during the Cultural Revolution, a period in the 1960s and 1970s when Mao encouraged local citizens to remove dissidents and traitors from the general population and leadership. Many intellectuals with scientific knowledge were persecuted as bourgeois, leading to abuse and death. Between starvation, a weak economy, and the attack on knowledge itself, it's no wonder that China's space efforts had trouble getting started. Despite Soviet assistance in the form of scientists and technology, China's first, most basic rocket, the T-7M, didn't launch until 1960. And after a breakdown in Chinese-Soviet relations soon after, China was left to figure out ballistic missile and space technology on its own. That was then, and this is now. Thanks to a much more successful economic policy shift introduced by Mao's successor, Deng Xiaoping, in 1978, China has grown from a mere 2.7% of global GDP in 1980 to a massive 16.9% in 2023. For comparison, the U.S.'s share has stayed fairly stable, 25.4% in 1980 to 26.1% in 2023. And with this economic growth has come more spending on space. China now spends the second highest amount in the world on its space programs, and this spending has allowed it to complete some very impressive projects. In 2004, China officially announced its interest in exploring the moon. They launched their first Chang'e probe, named after the Chinese moon goddess, in 2007 in partnership with ESA. Chang'e 1 orbited the moon and mapped its surface, achieving the goals China had set for it. But this was far from the final objective. China was setting the stage for a more detailed exploration of our closest neighbor. In 2013, Chang'e 3 became the first Chinese probe to soft land on the lunar surface, making China the third nation ever to accomplish such a landing. But China wasn't satisfied with being third, so in 2018, they tried something that had never been done before, a landing on the far side of the moon. The far side of the moon is cut off from communication with Earth, which means the only way to coordinate a landing there is with the help of an intermediary spacecraft to relay signals. Despite the difficult nature of this task, Chang'e 4 completed a successful landing and even carried a small biosphere with seeds, fruit fly eggs, soil, and air to see how this miniature ecosystem would handle conditions on the moon. Some of the seeds actually sprouted, making them the first plants to grow on the moon, although their lives were short as they died just a day later. Since then, China has finished 2 more Chang'e missions, with both successfully gathering samples from the moon and bringing them back to Earth. The biosphere experiment might have given you a hint about China's long-term plans for the moon. After all, why practice growing plants on the moon unless you are thinking about how to create a permanent base there? And indeed, this is China's long-term goal. In 2019, China publicly stated its plan to build a research station on the moon within the next decade, and since then has been inviting other countries to join. 13 nations and 2 organizations have already agreed to participate, including Russia, South Africa, Belarus, Pakistan, and Egypt. If this sounds familiar, it's because it has a strong similarity to what the U.S. is doing with the Artemis Accords, gathering nations to share in the benefits of space exploration together. In fact, state media often compare the International Lunar Research Station, ILRS, and the Artemis Accords as competing projects, although China doesn't seem keen for them to be seen that way. China has formally invited the U.S. and Europe to join the ILRS, although the U.S. might not accept due to American laws that forbid China-U.S. partnerships on space projects. It's possible that other European countries will join. It's not the first time ESA and China have worked together on space missions. ILRS construction missions are planned to start after 2028. As a side note, it was only recently, in 2011, that America passed the Wolf Amendment that banned collaboration between America and China without congressional approval. The U.S. was worried that China was learning too much from U.S. rocket technology. They didn't want China to reach places like the moon before them by using their technology. China's vision extends beyond just the moon, though. Just like the U.S., China has been considering exploring other planets in the solar system. In February 2021, China's Tianwen-1, meaning questioning the heavens, mission successfully entered Mars's orbit. It was made of 2 parts, an orbiter and a rover named Zhurong, which landed a month later on the Martian surface, making China the second country ever to land a rover on Mars. Zhurong spent about a year on Mars, using its radar instruments to map out subsurface water. It even had a camera similar to Perseverance's, capable of zapping rocks to better understand their chemical makeup. Once again, however, this was just setting the stage. China plans to bring samples back from Mars's surface to Earth by 2031, which, if they do it, would be about a decade ahead of NASA's own sample return plans, which are still very much in the development phase. Getting samples from Mars for study would be extremely beneficial for scientific research, as Earth's scientific equipment is far more advanced and precise than anything you can put on a rover, and it will definitely be a clear advantage for a nation thinking about how to best build permanent structures on Mars as they consider materials they might be able to find on site. A key to all of this is China having a strong enough launch vehicle. Whether it's moving base components to the moon or Mars, having a powerful, cost-effective, and ideally reusable rocket will open up the heavens to China's ambitions. It should not be surprising to you that such a rocket is well in development. The Long March 9 will be a super heavy version of the Long March series, aiming to carry payloads of up to 150,000 kcal into low Earth orbit. If this sounds familiar, it's because it's a similar number to what SpaceX's Starship is trying to achieve. The rockets are similar in more ways than one. Long March 9 will eventually become a reusable rocket, although early versions that will be ready around 2033 will only be single-use. The savings this provides is a game changer for any deep space construction projects China hopes to finish. An average Long March rocket costs about $3,000 per kilogram to get mass into orbit. The reusable nature of the Long March 9 could lower this to as little as $1,500, effectively cutting their launch costs in half. And China does indeed have other deep space construction projects. China has its own permanent space station, the Tiangong, or Heavenly Palace, a smaller space station than the ISS that can only house 3 astronauts in its 3-module setup compared to the ISS's 7 astronauts and 18 modules, but still remains an impressive feat of engineering and physics. The space station's primary core was launched in 2021, with 2 earlier generations tested in 2011 and 2016. Tiangong has been the home of many Chinese astronauts, or taikonauts, and spacewalks, and shares an orbit with the Suntian Space Telescope, making it a good staging point for any repairs the telescope might need. China wanted its own station partly because China was excluded from the International Space Station. Again, U.S. law prohibits China and the U.S. from working together when it comes to space, for fear of China stealing technological secrets. For the record, NASA and Chinese scientists are much more in favor of working together. For instance, when China got samples from the moon, NASA asked for permission from Congress to let them look at what China found. China itself was more than willing to share. Building international goodwill seems to be a core part of its long-term space goals. China's space station is similarly open to other nations for doing scientific experiments, and although no other nations have yet visited the smaller 3-module space station, 9 different international scientific projects from 17 different countries have been agreed upon, including participation by UN members. Again, scientists generally do not care about the nationality of other scientists, as long as they have a good chance to do good science together. It tends to be governments that do not fully trust other governments' motives, although maybe this is for a good reason. All of this paints a picture of China's long-term goals, a desire to explore and set up permanent bases across the solar system. And indeed, if you look at China's long-term plan projects, you can see this take shape. China plans to send probes to explore Jupiter and its surroundings, planning to launch in 2030. It plans to launch 40,000 satellites around Earth to improve its satellite coverage and its ability to compete with entities like Starlink. And Chinese scientists have proposed a long-term plan for developing resource collection and logistic supply chains across the entire solar system, to be finished somewhere by 2100. This is not an official government plan, but it's a fascinating look into what China might be thinking about in the future. The plan talks about asteroid mining using water ice found there for fuel supply nodes and logistics chains spanning across the solar system. In the long term, China is thinking about how to get the most benefits from space while outwardly working with international partners as it does so. So, will China surpass the U.S. when it comes to these kinds of goals? That's one possible outcome, and it's certainly what U.S. intelligence analysts were worried about when they wrote that D&I paper in 2021. But there are 2 other futures that also seem possible. As things are, the U.S. still spends more than China on space by a wide margin, $73.2 billion compared to China's $14.5 billion. This means the U.S. spends more on space programs than every other country in the world combined. So although China is second on this list, NASA's lead is not currently under serious threat. As long as this kind of difference continues, it seems unlikely that China will overtake the U.S., even if some Chinese projects are moving ahead of NASA's. Overall, the U.S. is continuing to learn more about space and will stay dominant in that area for quite some time. Then again, China's budget size could be misleading. China can finish its projects much more cheaply than the U.S. thanks to its more affordable labor, especially if it's willing to cut corners on safety. But perhaps the most positive outcome is that it stops being so much of a competition in the years to come. As nations start to set up not just occasional space stations or research outposts beyond Earth's orbit, it will become increasingly important to have some kind of common rule that all nations follow, detailing the rights of certain nations and organizations to the resources scattered across the solar system. Rather than having the U.S. and China form 2 rival groups of nations, hopefully in time we can have one common rule book that both nations are playing by. I fully expect both nations to keep trying to outdo each other within that framework. Competition seems to be human nature, after all, and neither China nor the U.S. seem to be above it. But at least it should be done with the understanding that they can sometimes work together as well as compete. That's the only way space will be for everyone, after all. The U.S. is not the only large fish swimming in these waters. 100 years from now, the map of the solar system will not only be decorated with red, white, and blue flags, but will also be home to many that are red with 5 stars. So, what are your thoughts? Should the U.S. look for ways to work with China on space missions, or is trying to protect America's technological lead the main concern? Leave a comment below and let me know what you think. We don't often cover Chinese space missions on this channel, as their findings are not public domain like NASA's are, making it harder to get images and information on what's happening. But I'm interested in what you thought about this exploration of another country's space program. But for now, thanks for watching. I'll see you next time. On the moon, the real estate market is booming. While I'm being a bit playful when I say that, it is true that interest in the moon as a permanent home for humanity is on the rise. Before December 2022, the number of countries and political unions that had successfully sent probes to either orbit or land on the moon had grown to 6. America, Russia, Japan, Europe, China, and India have all dispatched spacecraft to our nearest celestial neighbor. The reasons for this differ, even within the same country. For some, it's about scientific progress. For others, the moon presents plentiful opportunities for economic profit. But regardless of the motives, knowing where to build those first lunar bases is becoming more and more important, and that means mapping the moon's surface and features is more critical than ever. Luckily for everyone involved, the Lunar Reconnaissance Orbiter, LRO, has been circling the moon from an altitude as low as 50 kilometers from the moon's surface since 2009. Its mission has been to map the moon's surface in great detail and to enable scientific discoveries that help us understand the processes that happen there. We have talked about what it has seen before, but we've only just begun to explore the moon's haunting beauty and deep mystery. What has the LRO found up there? How does it relate to humankind's reach for the world beyond our atmosphere? And how might its next generation take that search even further? And today, in my 6th video on the LRO, you're about to find the answers to those questions. As a quick summary, the LRO was launched by NASA in 2009 as a way of mapping out the lunar surface in previously unmatched detail. But when this was done after just 1 year, NASA changed LRO's mission to look into areas of special scientific interest. We've talked in my last video about the highest and lowest points on the moon, as well as rills and some truly impressive impact craters. But that is not the thing of greatest value to future explorers. In fact, one of the most important features on the moon is a simple hole in the ground. This is a pit crater. By looking at the shadow, scientists can tell that it's a massive 100 meters deep and 100 to 115 meters across, depending on where you measure it around its sharp edge. Unlike impact craters, which are made from space debris crashing down onto the moon's surface, it is thought that pit craters like this one are formed by a cavity collapsing deep underground, similar to the process that makes sinkholes here on Earth. This gives more proof that under the moon's surface, networks of caves and vents may exist, possibly formed by flowing lava long ago. The moon is cold now, so these lava tubes are empty. But this gives astronauts and scientists a unique chance. If they do exist, it's very likely that lava tubes will provide a remarkable, easily accessible record of the geological processes that shape the moon. They might be coated in interesting and rare minerals. Furthermore, it's much easier to set up a base on the moon if your walls and ceiling are already made for you. Lacking a magnetic field or any significant atmosphere, the surface of the moon is completely exposed to solar and cosmic radiation. Over time, this radiation could give a lethal dose to any potential settlers. The only way to avoid this would be to line your buildings with thick materials to block out the radiation, but 100 meters of rock will do the same thing just fine. If pit craters provide a door to cave systems 100 meters deep, astronauts may very well choose a site much like this one to settle on the lunar surface. Of course, any potential settler will not only need protection from radiation to survive on the moon, they will also need access to water. And it's here that LRO has provided some more fascinating insights into the moon's surface processes. It was once thought that the surface of the moon was dead and dry. If water existed, it would only be found in small pockets in permanently shadowed areas. However, as LRO traveled over the lunar surface, it started to notice something unexpected. Trace amounts of water molecules could be found over the top of the surface regolith, the gray rock that makes up much of the moon. It turns out the moon is ever so slightly wet. This wetness was even seen to move around in a sort of lunar water cycle, both by region and by time of day. Around noon, when the moon's surface was hottest, the water seemed to disappear, but then would come back with the evening. Scientists do not fully understand this process. Where did this water come from? Why did it not all evaporate into space? But LRO's observations mean that the places on the moon that might be usable for a lunar base are suddenly much wider. If this trace amount of water could be collected, you would not need to build your base next to a permanently shadowed region, which is convenient because permanently shadowed regions are far colder than we first thought. The moon has very little axial tilt, a little over a single degree. This means that at the poles, craters exist that are never directly exposed to the sun, no matter the time of day or year. The sun never shines light into their mysterious basins. Naturally, a place that never gets any sunlight is going to be cold. However, scientists were not ready for exactly how cold these regions turned out to be. For context, at the equator, temperatures on the moon change between 120 during the day and 130 during the night. LRO has a diviner instrument which uses 7 thermal infrared channels to measure surface temperatures. With it, LRO found a polar crater that had temperatures as low as 250 degrees, making it the coldest temperature measured on any object in the entire solar system. That's colder than the average temperatures of Uranus, Neptune, or even Pluto. The crater edges protecting these areas from solar radiation might have created the perfect storage place for holding water ice. But other, more interesting useful compounds could be found there too: carbon dioxide, carbon monoxide, dinitrogen, and argon. Perhaps these compounds could be useful for settlers, and so getting to these materials might be very beneficial despite the freezing cold. But because it's so dark down in these craters, it's hard to know for sure exactly which craters have what. It would be a shame to build a scientific base only to find that the crater next to you was completely empty. Sadly, LRO's onboard camera, the LRAC, is not able to see through this darkness, but there is a new camera circling the moon that can. The reason why I said in the introduction that 6 countries had sent probes to the moon before December 2022 is that on the 16th of December, that number actually went up to 7 after a 4.5-month journey. South Korea's Danuri probe just arrived in lunar orbit. NASA has actually been working closely with South Korea on Danuri, giving them scientific expertise and communications and navigation support in a spirit of mutual international scientific collaboration. In thanks, South Korea's Kari space program gave NASA 7 kilograms of space on their Ikari Pathfinder lunar orbiter, or Danuri, as it's locally known. A compound word made from dal, meaning moon, and nuri, meaning enjoy. NASA thought about which scientific instrument could be best placed on Danuri, and in the end, they chose a device known as shadow cam, a younger sibling of LRO's own narrow-angle camera, with one major improvement. Thanks to its 200 times sensitivity, it turns images like this into images like this. This incredibly clear image is of Shackleton Crater, found at the Moon's South Pole, the first ever site photographed by LRO, and now, thanks to Danuri and ShadowCam, we can properly look into its inner basin. It turns out that Shackleton does not look very different from many other craters on the Moon. Its cratered floor is covered in bumpy hummocks. Sadly, there is no obvious ice here. Perhaps this is because Shackleton is a smaller crater, which means that the temperatures inside do not drop quite as low as would be needed for ice to reliably form. One point of interest is the clear trail left by a boulder as it rolled down the crater side, visible near the top of the image. Such tracks are common on the Moon, as the lack of wind means that any disturbance of the dusty ground is never covered up again. This track could be very old. This is the only image released by ShadowCam so far. However, Danuri plans to orbit the Moon for at least the next year. In that time, it will hopefully light up the shadows on all of the Moon's hidden terrain. So, there you have it. Thanks to the LRO, and now Danuri, the surface of the Moon is being mapped in increasingly clear detail. Processes such as the lunar water cycle are being understood more deeply, and the path is being laid for future missions to actually land on the Moon through the discovery of compounds vital to human life. And that's not even mentioning the developing scientific understanding of the Moon's origins and history that is emerging as we uncover its geological record. When scientists one day arrive on the Moon to study this record firsthand, it will be thanks to this data that they will know where to go. As the number of nations settling on the Moon increases, they will rely more and more on LRO and the information to know where to build. That's what excites me most about all of this. We are metaphorically, brick by brick, laying the foundation for possible future civilizations, thanks to the knowledge being developed by these orbiters and pathfinders. One day, millions of humans might just call the Moon by another name, home. When you think about the space race, you probably picture the tense Cold War era competition between the US and the Soviet Union. But what if I told you there was another player in the game? While the superpowers fought for space dominance, a small and newly independent nation started to develop its own dreams of reaching the stars and beating the major players. The story of Zambia's space program is a powerful example of humanity's overriding curiosity to explore and understand the cosmos, no matter where we come from, and the lengths we are willing to go to achieve this. It also serves as a reminder that history is written by those who get to tell it, and it's not only the loudest voices that leave the most important legacies. Join me today as we explore the little-known story of the Zambian space program, their proposed mission, unusual training methods, and the lasting impact of their leader's vision. After World War II, the U.S. and the Soviet Union realized that in a world with nuclear weapons, there could only be one superpower. They entered a bitter fight for dominance, each trying to stay one step ahead of the other, creating more and more powerful rocketry and weapons technology. It didn't take long for their arms race to turn into a space race. By the early 1960s, new milestones in space exploration were being reached every year. Both programs had strong political and public support, which meant a lot of funding, press coverage, and progress. All eyes were on them, and the stakes were very high. Half a world away, Edward Mukuka Nkoloso was watching too. A passionate science school teacher, he dreamed of one day creating his own Zambian space program to compete with those of the Americans and Soviets. The only problem, his country was dealing with its own political struggle, the fight for independence. Zambia, then known as Northern Rhodesia, had been under British colonial rule since 1888. Throughout the 1950s, Zambians grew more and more unhappy with colonialist policies like racial discrimination and limited political representation for Africans. Nkoloso was one of these Africans. After fighting in World War II on behalf of Britain, he started a school for Zambians, which was quickly shut down by the British authorities. This forced him to join the Zambian resistance movement and later the United National Independence Party. Nkoloso also worked hard on both causes close to his heart, While on one hand he was fighting for Zambian independence, on the other he was building the Zambia National Academy of Science, Space Research and Philosophy, which opened in 1960. The details of what happened at his academy are not clear, but it seems this is where Nkoloso's idea for a Zambian space mission came from. He was going to send Zambian astronauts, or Afronauts as he called them, to the moon and then to Mars, and he was going to do it before the U.S. or the Soviet Union. We have been studying the planet through telescopes at our headquarters and are now certain Mars is populated by primitive natives, he said. Specially trained space girl Mata Muwamba, 2 cats, also specially trained, and a missionary will be launched in our first rocket. But I have warned the missionary, he must not force Christianity on the people of Mars if they do not desire it. If you're wondering about the cats, they were included partly for companionship for Muwamba and partly as a survival testing device. Muwamba was to release one onto the Martian surface upon arrival, and if it survived, she would know it was safe for her to come out too. In 1964, Nkoloso announced his mission was ready. The first rocket was planned to launch on Zambia's Independence Day, October 24, 1964. Now, going into space is never an easy task. You have to be in top physical and mental shape to be an astronaut. In the early days of the space age, some training exercises were very tough or even dangerous. In the 1960s, cosmonauts went through all sorts of hard physical training and conditioning. For example, they were put in a centrifuge to copy the intense G-forces of launch, which is very dangerous as it puts a lot of strain on your heart and lungs. Such training could lead to a lack of oxygen and cause trainees to pass out. It also makes it hard for your heart to pump blood up against gravity to your brain and other vital organs. Long-term exposure to multiple G-forces can lead to problems like arrhythmia. Over time, cosmonauts also did parabolic flights for weightlessness training, named for the parabolic flight path the aircraft follows. At the top of the curve, the acceleration of the aircraft cancels out the acceleration due to gravity, creating a feeling of momentary weightlessness for the passengers. It's like being on a swing, and at the highest point of your swing, you feel weightless for just a moment, except in an aircraft with the right path, you can feel that microgravity for up to 40 seconds. While effective, these flights were risky because of the high chance of mechanical failure or pilot error, as only the most skilled pilots at the time could do the precise maneuvers needed. Cosmonauts also had to be ready to face a very harsh environment in case their mission might land far from recovery zones. Wilderness survival training in Siberia was a key part of mission training, which sounds absolutely brutal even in modern times. The lengths some will go to reach for space can be quite dangerous. Daredevil Mike Hughes found that out after building his own homemade rocket in an attempt to prove his belief that the Earth is flat. In February 2020, His rocket tragically malfunctioned during a test flight, killing him instantly. While no one died in the Zambia space program, its training certainly made people raise their eyebrows. Uncoloso created a series of mental and physical tests to get his astronauts ready for space travel. One such exercise involved teaching his recruits to walk on their hands, saying that this was the only way people could walk on the moon. It's not clear where that idea came from, as he was an educated man and probably followed the latest space race updates closely. To simulate zero gravity, he would put his recruits in an oil barrel one by one and roll them down a hill, bouncing them over rough ground to simulate turbulence. When they hit a particularly large bump, he celebrated, saying they had just experienced anti-gravity conditions, an exercise that is obviously uncomfortable, potentially dangerous, and definitely not scientifically sound. Another approach they took to weightlessness training actually involved something I mentioned earlier. They tied 2 ropes into a swing and would swing on it, going higher and higher. At the moment they least expected it, another trainee would cut the rope so they could feel the free fall to the ground. Not a much better approach. And the rocket ship they were training for? It was a 10-foot oil barrel with an air hole in it, made of space-grade aluminum and copper. Want to know how they were initially planning to launch it? With a catapult. His willing recruits were a group of 12 teenagers he was training at the space program's headquarters, a secret location 7 miles outside of Lusaka at an abandoned farmhouse. Mata Muwamba, the girl who was supposed to actually fly the mission, was just 16 years old at the time. NASA had ex-military Air Force pilots and engineers in state-of-the-art, purpose-built facilities, and in Coloso had a dozen high school children in a field. Now, I know it seems like I'm making this up, but this really happened, as crazy as it all sounds. And that's what's so puzzling about Coloso. He was an intelligent person. He wrote about space, he was a science teacher, a veteran, and a valued member of the political movement that led to the nation's independence. So what was his final goal? Why was he talking about this mission if he must have known it wasn't possible? Some have guessed that his motivation to join the space race came from a place of national pride and a desire to raise not just Zambia, but all of Africa to the world stage. He was seen as working to break down stereotypes about Africans that had stayed during the colonial era and instead show that Africans are capable of contributing to scientific and technological progress. If his goal was to get international press attention, he certainly succeeded. Time magazine published an article about him, as did several other outlets. News crews traveled to film video interviews with him and record his team training. His colorful personality and wild claims definitely helped capture public imagination and media curiosity, even if it wasn't clear whether he was serious or not. Coloso stayed serious about it until his death in 1989. When asked about it in 2016, the first president of Zambia, Kenneth Kaunda, said it wasn't a real thing, it was more for fun than anything else. There's another theory that his whole project was satire, a parody of the Western conquest of other nations. There didn't seem to be a reason for such goofy-looking training exercises other than to get people's attention. Even during his interviews, he always stayed in character with his standard issue helmet and flowing cape. But he would add subtle jabs at the world powers, calling them imperialist neo-capitalists who were scared of Zambia's space knowledge. Remember the Christian missionary he wanted to send to Mars with the girl and the cats? He had specifically warned the missionary he must not force Christianity on the people of Mars if they do not desire it, a luxury many colonizing nations did not give their conquered lands. Perhaps not surprisingly, Coloso's project never got public or political support. He had written to UNESCO asking for a $7 million grant to make his mission a reality, a tiny drop in the bucket compared to NASA's $25.4 billion Apollo funding. It's also been reported he sought $1.9 billion from private foreign sources, but the Ministry of Power, Transport, and Communication was quick to clarify this request was not made on behalf of the government. In the end, the only funding he got was 10 rupees from a young Indian boy. Most Zambians did not connect with the space program and did not feel it accurately represented the feelings of the nation. In fact, his own astronauts left him. 2 recruits reportedly went out drinking one night and were never seen again. Another left to join a traveling song and dance group, and Mata eventually had a child of her own and stayed at home instead of going to Mars. Looking back, we can only guess about Nkoloso's true intentions. Maybe it was a trick to get international headlines and publicize the name of a newly independent country. Given Nkoloso's history as a revolutionary, it wouldn't be out of character for him to want to replace the name Northern Rhodesia with Zambia on the world stage. And while he had everyone's attention, he might have thrown in some satire aimed at the superpowers just for fun. Or he might have hoped, against all odds, that their hard work and determination would impress the right people and actually launch Zambians into space. Or maybe he was just trying to make some children feel like they were part of something significant and important. What we do know is that he never let setbacks weaken his determination and belief in his vision. Thanks to him, even for a short time, Zambia entered the space race against the U.S. and the Soviets. This is a vibrant story of one man's audacity, determination, and self-belief. The reality is that not everyone who dreams of going into space actually goes there. But whether he meant to or not, Nkoloso told the world, "We are here, we are Zambian, and we are free." In a way, he reminded us that those epic, larger-than-life endeavors, like reaching for the stars and exploring the vastness of the universe, come from a desire that is in all of us, and that in itself makes it a story worth telling.